At a certain factory, 10% of the staplers produced on Monday were defective, and 2% of the non-defective staplers were rejected by mistake. If 90 of the non-defective staplers were rejected, what was the number of staplers produced that day? So this seems like an overlapping set question. We got a bunch of staplers, and the staplers can either be defective or non-defective. And they can either be rejected or not rejected. And so let's start filling in things. So at a certain factory, 10% of the staplers produced on Monday were defective. So that means we got some amount of staplers that were produced. I'll call that T. And then 10% or 0.1 T were defective. And so if 10% were defective, that means 90% or 0.9 T were not defective. And 2% of the non-defective staplers, so 2% of 0.9 T were rejected by mistake. So that is 0.02 times 0.9 T, and maybe I won't multiply this out just quite yet. I want to set it up first. So if 2% of the non-defectives were rejected, that means 98% must have not been rejected. So that would be 0.98 times 0.9 T. If 90 of the non-defective staplers were rejected, so this is now telling me this guy here, this box here, so 0.02 times 0.9 T is equal to 90. What was the number of staplers produced that day? So what is T? So I see exactly how I'm going to solve for T. They're asking for T. I have an equation here involving T, so I'm just going to solve this equation. So 0.02 is 2 over 100, which simplifies to 1 over 50. So I got 1 over 50 times 0.9, which is 9 out of 10, times T is equal to 90. So this becomes what, 9 over 500 times T is equal to 90. So T should be equal to, if I multiply each side by 500 over 9, T is equal to 90 times 500 over 9. And it looks like the math is going to work out very nicely here. 90 over 9 is just 10. So T is equal to 500 times 10, which is 5,000 staplers produced that day. E.